All right, so this is 3.4. 3.4 is using inverse functions. So in order to use, we have to find. So first we will be finding an inverse relation. An inverse is quite frankly the exact opposite. So essentially, when you think about an inverse function, it would be when their x and y values are 100% flipped. So an inverse of a quadratic, remember a quadratic would be a parabola like a U. An inverse would be a parabola on its side. So a U kind of laying on its side like that. You switch the x and y values and it's an inverse. So when we find an inverse, there's a few set steps that we kind of take. First, if it is an f of x function, okay, we're going to find the inverse of this function, f of x equals 3x minus 5. You first have to start with replacing f of x with y. Remember, f of x and y, g of x, all those kinds of things are very interchangeable. So we want to say y equals 3x minus 5. After you've replaced f of x with y, you then want to literally switch your x and y. Nothing else, everything else stays, but just your x and your y. So it will now be x equals 3y minus 5. A lot of people get tempted to take that 3 with it, with the x, but you want to leave everything behind. After you've switched, you now want to solve for y. So I'm going to get y by itself. The first step in doing so will be getting rid of this 5. I add it to both sides to get 5 plus x over, or equals, 3y. X plus 5, either one doesn't matter. Then I would divide by 3 to get 5. That feels weird. Let's do x plus 5 all over 3 equals y. This is what we're going to claim as our inverse function. The way that you say something is an inverse is you say f, and then you say like to the negative 1 of x. This means f inverse of x. F inverse of x. That would be x plus 5 over 3. But we can't say, yep, that's awesome, that's my inverse, I'm done. We have to, secondly, verify the inverse. So this is where composition of functions comes in huge. If you're not comfortable with those, you won't be comfortable with any of this verification process. You have to do two things. The first is taking f of f inverse of x. The second verification is f inverse of f of x. So look, these are compositions of functions assume with the f of x and f inverse function. So let's look back. Our f of x is 3x minus 5, and I'm going to write that down here underneath the inverse, just so we kind of have both of them in the same window screen. So for the, let me see if I can get this all in the same, there we go. For the first verification, and you can swap these, it doesn't matter which one comes first. But I start with my f of x function, that's this one, and I insert my f inverse for every x I see in this first function. So the f of x function is 3, and then I see x, so I open up a parentheses. Instead of an x, I put the entire f of x, f inverse function, which is x plus 5 all over 3, end parenthesis. And then that's my x. We continue on with the minus 5. All right, that's the setup for that one. Let's do the setup for the other one. We'll come back to the other one, but let's do both setups. F inverse of f of x, I start with my x plus 5 over 3, right? That's my inverse, except right away I run into an x, so I open up a parenthesis. Put my entire f of x function, which is 3x minus 5, close that parenthesis. Now I'm back to my f inverse. This was my x right here. This part was my x. So now I continue on with the plus 5 all over 3. So let's look at the two different setups of functions that we have. Both of these compositions are set up now. We have to simplify them. If we can get down to both x and x, the function will be verified as an inverse. So first thing over here, when you have a big 3 is what I'll call it, and then a 3 in a denominator, those end up canceling each other out, leaving me with x plus 5 minus 5. Plus 5 minus 5 cancel, leaving me with just x. So ching, that one is verified. Let's go over to this one. Right away, I'm seeing x minus 5 plus 5. Those are canceling, leaving me with 3x over 3. You don't want to do too many steps at once, okay? I could have seen, oh, well, these will cancel too, but that's not mathematically correct yet. I want to wait till this point, then I can cancel and say, yes, it is in fact an inverse. So down at the bottom here, I'm going to say f inverse of x is, I don't know how much you can see this, there we go, is x plus 5 all over 3. And then I can box it up and I can call it good. All right, that was an entire problem for finding and verifying an inverse. Let's see, that one is really similar, so we don't need to do that one. I'm going to do one more example with you. These truly don't need to be too incredibly example heavy, because essentially it's the exact same process. There's just maybe some different kinds of functions you'll see. So the one other one that I do really want to show you is find the inverse of y equals 1 over 27x to the third, right? 1 over 27 times x to the third. So notice our first step is already done for us. We generally need to replace f of x with y. It's not an f of x to begin with, so that first step's already done. Now switch x and y. So we have x equals 1 over 27 y to the third. I now want to solve for y. To get rid of 1 over 27, it's multiplied by y. So to get rid of multiplication, you have to divide. I would be dividing by 1 over 27, okay? So let's do divide 1 over 27. When you divide by a fraction, okay, like we are right here, it's the same thing as multiplying by the reciprocal. The reciprocal is the flipped version of it. So instead of dividing by this fraction, I'm multiplying by 27 over 1, or just 27. So I have 27 times x equals y cubed, okay? Again, this is truly 27x equals y cubed. To get rid of a cube, you have to take the cube root, giving me f inverse of x equals the cube root of 27. And there should be a cube out in front there, okay? So I'm claiming that this is my inverse. Now I have to verify. My original y was y equals 1 over 27x to the third. So remember, y can be replaced with f of x. So this is my inverse, this is my original. So let's take f inverse of f of x. I am starting with my inverse function. So I start with the cube root. Then I get to a 27. And then all of a sudden I hit x. So now I want to replace this x with my entire original function, which is 1 over 27 x to the third. Okay, that's the setup. Let's get the other setup done. F of f inverse of x. Okay, starting with my original f of x, that is 1 over 27. And then I run into my x, so I plop a parenthesis, go back to my inverse function, write all of my inverse function. Cube root of 27x and end parenthesis. Now remember, I was on my original f of x function. So after the x comes a cube. So that cube does have to stay. Now let's try to simplify. 27 times 1 over 27 cancels to give me root 3 of x cubed. A cube root and a cube cancel, giving me x. Now cube root and cube cancel again, giving me 1 over 27 times 27x. 1 over 27 and 27 cancel to leave me with x. So my inverse is f inverse of x equals cube root of 27x. Box it up and I can say I'm done. All right. Again, if you're having issues with composition of functions, go ahead and reach out to me. I can help you as best as I can, especially if you're a remote learner. If you need anything, we can set up a Zoom meeting, we can email, whatever can help you the best. These two examples should have covered pretty much every kind of form of an inverse that you'll end up seeing, both in your homework and anywhere else. Okay, that is all. We are nearing the end of chapter 3, so maybe be looking for a quiz. Well, shoot, maybe we'll quiz even before we get to this chapter, this section. I'll let you know. Okay, bye.